partial quotients. What's a partial quotient again? Anna?
It's when the quotients get replaced, probably
Exactly, so it's breaking it up in that area model like we just did in the warm-up. So we're using partial quotients and place value understandings to divide with two-digit divisors. So I have a question for you. What are the names of each of these? Without looking up there. Thomas? What's the first one?
dividend.
How about the second one? Annie?
The divisor.
Divisor. What about this last guy? Lily?
Quotient.
Beautiful. So that's going to be really important today because we're going to be working with divisors that are two digits and dividends that are 3 or 4 digits. Not today. So this first one, I'm going to show you. So I want you guys to pay attention, but don't get stressed out because we're going to do a bunch of them. So we're dividing 408 by 12. So our first step, similar to what we've been doing, is we put the 12 over here because that's our divisor. The divisor goes on this side. So now we want to break up our dividend up here, like we have been with other area models. So what I like to do first is think of the different multiples of our dividend. So 12 times 1, we know is 12. 12 times 2, 24. 12 times 3, 12 times 4, 12 times 5,
12 times 40. Yeah, you
Oh.
12 times 40.
12 times 5 is
60.
60. So that's enough for me right now. I might go back and add some more. But I want to think about 408. So, what can we do that is close to 408? So I'm going to look at this and look at my multiples. I know that 12 times 3 is 36, which is kind of close to 40. So we know that that's right here. So I'm going to write 360 right here. What do you have to multiply 12 times to get 360? Tori. 30. So from here, we only have 360. How much is supposed to be in this whole box? Liksha? 408. So from here, we have to do 408 minus 360. 8 minus 0?
8.
40 minus 36, or 4. That's it.
Never mind. 60. Oh wait, I
10 minus 6.
Yeah.
So we have 48 left over. Do we know what 12 times something equals 48? Do we know something? This is a fact that we should know, right? Sydney?
12 times 4 equals 48.
Exactly. So we can put 4 up here, and we get 48. To check, we can add these two and make sure that we are still getting 408. But we know from this subtraction right here that we're getting that. So, we know that 12 times these equals 408. And therefore, 408 divided by 12 is
34.
34.
How could you check to make sure that the answer is 408?
Oh,
Braden.
Peter? Oh, sorry.
By multiplying the
Give him some support. What would you multiply to figure
Do
out
you wanna
if
call in
you
friends?
have that dividend?
You would do 34 divided by 12?
Divided by 12?
No, times 12.
Times 12, we're going to use, what's that word? What kind of operation is that? Multiplication and division's relationship. Peter?
Inverse.
Inverse, good.
So let's check it right here. 34 times 12. 4 times 2?
8.
3 times 2?
6. 4.
4 times 1?
4.
3 times 1?
3.
So if we add that, whoop, bring it over here, what do we get? So we get 8, 0, carry the 1, and 408. Check. We did it. Yes.
Did you know that all of the numbers in the, all of the numbers that, like 12 times 1 and all of those, they equal 36? Because I did 2 and 3 is 5, this 1 and 6. I'm doing the 10 space right now, so I'm doing 10 at the bottom, and then 5, 6,
For over
and
here?
16.
Oh, adding those.
Yeah, adding these, this is 16, and this is 20.
Very interesting. Yeah, that is pretty cool.
So it equals a multiple.
So let's try one together. Do we think we're ready for this? I think you are. You're going to help me. So, 912 divided by 24. What do we do first? I forgot. We have some new friends here. Can you introduce yourself to me?
I'm Chris.
Chris, I'm Miss Christie, and I'm an intern from Loyola. I totally forgot. Wow, it's very nice to meet you. And we have another one. What was your name? What is it? Jordan. Nice to meet you too. I look forward to working with you.
They
So
are
Chris-
gems.
I
We
can
just
tell
love
already.
them.
Chris, can you help me out? What do I do first?
Put 24
On the side of the box. What's next? Tori? Yeah, so let's listen. 24 times 2? 24 times 3? Sorry.
No, you put 2.
Oh,
No, you put
You're making me so many mistakes. This isn't you, Miss Christie.
no. 72. 24 times 4.
96.
Beautiful.
26. You said 26. Stop.
I think we'll stop there for now. We can always add more. Sydney, what do we do next?
So first, next you see which is the closest multiple to 91, which is 72. And
Why'd you use 72? I think that 96 is closer.
but you shouldn't go over.
There you go, Sydney. That's awesome.
Why not?
Because that'll change the problem.
There you go.
Nice job.
Exactly. So we know that 72 is the closest. What do we do with that? We know that 72 is the closest. So now what? Liksha?
We do 72. Wait. We round, not round, but make the 2 a 0, and then put 72 at the bottom of the 92. 91.
So that's similar to what you were doing with the 1 digit times whatever it was, but we are going to do all of our subtraction and other work below because it gets a little confusing when you have the 2 digits. So from here, we're going to write 720 because we want to make sure that we're still keeping those 3 digits because it is 912 and not 91, right? So 720. Now what? Anna? And why is it 30? 720. So this section right here is really 70 Oh,
Did it 720?
exactly. Why are we doing that? Oh, Peter?
So we can get that number in order to be closer to 24.
And that leaves us, so 720 is what we already have here. We want to find what's left over to get us to that 912. 912 minus 720. 2 minus 0.
2.
1 minus 2.
Can't do that.
11 minus 2.
3.
9. 8 minus 7.
1.
So we have 192 left to find in this box over here. What do we think we do next? Yes.
Since 192 is not a multiple of 24, you should round it.
Yeah, we're not going to go over. What do you think, Tori? I like the way you're thinking, but I think we have to do another step in order to find a number that's close to this. What was your name again? Jordan. We need another few multiples. So, 24 times 5. 24 times 6. 24 times 7.
168.
24 times 8.
192.
192, not 192.
It's right there. So, we know that this multiple right here is what? How do we get 192? 24 times what?
8.
So then this is 1.
And the
Yes.
answer is 38.
So, what is our answer? 38. And how do we check this? Do you want to come up and check it for us? No. Annie, you want to come up and check?
Give her some support.
Let's give her some support.
Make sure you're sitting down and watching.
You might have to write it.
Okay, now do it. Ooh, quiet support.
And is that what we started with? Yes.
Ooh, it's the same
Wow.
digits.
Yeah, it is.
Would you mind if I jumped in for a quick second?
Yeah.
Do you have to do it this way?
I was just gonna think the same thing.
Can we stop a different way?
Wait, mine stay alike.
Do I have to list my multiples all the way this far, or could I have done maybe 120 and taken it away and then broken it apart again?
So if we look at that, sometimes it's not forward.
It's going to depend, because if you are having a hard time listing your multiples of 24, to get that far, this might be an easier way to do it. So let's think about it this way. What if I said, okay, 24 times 5 is 120. That's a really friendly number. So I could say, all right, 24 times 5 is 120. Then what am I left with? I started with 192, and then I subtract 120, and what's left? want to list them all the way out this far, you can break it apart into more friendly numbers for yourself. It's up to you. It's how you want to think about the problem. Everyone understand?
Yes.
Question?
So, since 120 plus 72 is 192,
Exactly. You're just breaking that number apart to make it easier to solve. Exactly. You know what I mean? Where? Here? With 192 minus 20 is 72,
And then
and then 120 plus 72 is 192. It's a fact family with addition and subtraction, definitely. Your fact family for multiplication and division would be this entire problem. Okay? Yeah? You're just
That's
making
exactly
more
what
partial quotients. Instead of having 30 and 8, you have 35 and 3. That's the only thing you're doing. If it's easier for you that way, do it. If not, that's okay. It's up to you.
And because we just discovered that we can break it up differently, we have to remember that our friends might do it differently, and we can't just jump, no, that's not right. We have to think about what everyone's doing. We can learn from each other that way, right?
Okay?
Let's try that.
Right.
Does someone want to read this out loud? Cadence? Let's listen to Cadence. So what's our initial problem that we're solving up here? Chris?
Oh boy, that one looks different than the last two we've done, huh?
Oh yeah. What's different about it? 4 digits. Thanks, Brian. So what's our first step? Yes, Tori?
List out your, well, put 25 beside of the dot.
I like to put 25 over here first, just so that I remember what multiples I should be listing out, so that we don't get confused. So we can start with some multiples. 25 times 3 equals
125.
I'm going to stop here for now, because I think with this one, we can kind of think about it, right? So, what should we start with? Yes. Tori?
Make the 2 and the 5 0, make the 20
From where? Oh, here,
Yeah.
25. Okay, we can make this 25. But do we know what is that multiple? I think we can find that.
25 times what gives you that?
Alicia? 100. That's pretty easy if you think about it that way. You don't even need your multiples. At least not yet. So, what do we do now? Cadence? You got what?
Why is it confusing to write your subtraction in the box?
Because sometimes we'll have, depending on how you break it up, you can have like 5 different ones. So then the boxes start to get tiny. And then you start writing and you forget which numbers. Is it this number that I have left? Is it this number? If you can remember what's written in your box, that's okay. But I just think that it's easier to write it underneath and easier to see. Does that make sense?
When we solved it with 1-digit divisors, we were writing it inside the box because we were estimating. We're not estimating now. We're using multiples, we're using straight facts, and that's also another reason why I think Miss Christie likes it this way too. Me too.
Again, we're not estimating, we are finding the actual answer using real facts, which is really awesome. So when we subtract this, you get, wow, 2 we do next? There's a few different ways we can go about it. Tori, what do you want to do next? Anna, sorry. Do you have another idea, Sam? That is definitely one way we can do it. What's another one?
That maybe since 125 times 5, 125 times 5 is 125. Multiply 5 by 2, that's 10. 25 times 25 times
Teachers,
10.
pardon this interruption, but if the band members could please make their way down to Miss Giaggio at this time, the band members, not orchestra.
Friends, do we even need to solve it like that?
No. You can
What I heard something over here. Oh, Brayden,
add those two.
you can. So, what am I gonna take away then?
You could add that. And that gives you the answer. Yeah.
Well, this plus this gives you the answer. We know that because we just subtracted here, but we want to find what multiple finds that, gives us that number. We're still trying to find our answer up here, right?
So right now, what's inside that box? We can always erase it. What's inside that box there? 225, right? But we're just trying to find a way to make sure it makes sense for us.
So we can start with 125 because we know that 25 times 5 is 125. So if we start with 125, what is that in multiple? 5. So then what are we doing? What do we do next from there? Sydney?
Those two, and then you subtract it from 2,725, and then you get 2,625,
So for this, I think that you can just bring this up. 225, because that's what we have left after we already subtracted our 2,500. We have 225 left. But if we subtract from that for 125,
Get 100.
we got
So
100.
it's 25 times 9.
and then 100 is the box full of it. So then that's 4.
Whoa, hold on.
109.
So let's look at this again. 100 plus 5 plus 4. Well, let's step back. Step back one step. So instead of looking all the way up to the multiple that gets you 225, we chose to break it up. We had our highest multiple was 125 that we already listed out, so we used that. You can use almost any multiple up to 25, and it'll get you the same answer. So we get 125. We subtract from what we had remaining to get 100. So now all we have left is to find 100. So we want to find what times 25 equals 100. And that's where we got the 4. Does that make sense? And then from there, we know now that it all adds up, and we can check to make sure it adds up by adding what's in the boxes. So 2,500 plus 125 plus 100 equals our 2,725. So what is our answer? Tori, did you have a question? Anna, I keep doing that. Tori, you're right there. Anna?
I wanted to say that it's since we found that it's 5 plus 4, we now also know that 25 times 9 equals 325.
Awesome. You can learn from this that this combination right here, this 5 plus 4, is 9. So 9 times 25 equals everything in these two boxes. That was an awesome realization. So now what is our answer? Lakesha?
I got another statement.
Oh, you have another statement. Anna, move your clip up. That was awesome. Yes, Miss
Can I
A.
add something too?
Yes.
So I heard Sydney explaining what she would have done next, and she said, I'm going to add 2,500 plus 125. And then I'm going to subtract it from 2,725. Do you think you still would have gotten that 100? You would have. Miss Christie is saying, listen, you only have 225 left. Just take away what you're dealing with and get the rest. You don't need to go through that second step. So Sydney, your reasoning made sense 100%, and it's what we've been doing with one-digit divisors. But here, since there's so much extra work with the multiples, we're going to try to take that little shortcut, which is awesome. But great thinking on that.
And if that makes more sense to you, that is okay. But just remember that when you are subtracting this 125, 225 does not make up this whole box here. It only makes up what we have left. Does that make sense? So what is our answer? Yes. 109. And we can check by doing what?
Oh,
Peter?
multiplying, and I just did number math.
And did it work?
Yes.
Beautiful. So what are we multiplying?
109 and 25.
And Peter checked it and got 2,725. Awesome job. So, we are going to do one problem on our Smart Pals. Just because I wanted to do that before we go off to our own work.
You know what the Smart Pals are.
You used them earlier this year. If I can get Tori and Sydney to help me and Annie to help me with test it out.
Can they talk to each other when they try to solve this problem?
Oh yes, of course.
And just like Miss Christie was saying, don't say to another person that thinking is wrong. They might be trying it a different way.
Try it on your own, but you can work with a friend to talk about the different ways of doing